Hello. In this section, we are going to do some simple application of Taylor series and let you have some idea why do we learn Taylor series. Okay. So the first thing is approximate a function by using Taylor series. Okay. Approximate a function f(x), okay, by using Taylor series. For example, in the future, when we evaluate an integral of a function in calculus 2, we evaluate some kind of functions by using some techniques, right? But sometimes if the function is very complicated, and we don't know how, we don't have any certain method, for example, how to evaluate integral of this one is so difficult. We didn't learn any method in calculus 2 to calculate this, but we know the Taylor series for this function, which is x minus x cubed over 3. So the table is in the last section. Okay, and then this is approximation of the function tangent inverse x, and if we have more terms, it's more accurate. Okay, and then we can just do integral of the Taylor series, and then we can easily find it. So it's going to be x squared over 2, x to the 4th over 12, plus x to the 6th over 30, and minus x to the 8th. Something like this. And then we get approximation. So this is approximation of this integral. Okay, so that's the first application. Approximate a function by using Taylor series. And the second one, we learned this in the last section. Evaluate an indeterminate form limit. So for example, 0 over 0, infinity over infinity type. Even we can use L'Hopital's rule, but sometimes Taylor may be better. Okay, we can use Taylor function. And the next, I'm going to show you another thing is pretty interesting. You will use this identity in the future a lot. Okay. So this is e to the I theta equals cosine theta plus I sine theta. You may have already seen this in your physics class. This is called Euler identity. This is very useful in engineer. Okay, so that means we can express the complex number by using like a two part, real part and imaginary part. So let's take a look why we have this. Firstly, let's write down the exponential function Taylor series. That is 1 plus x, 2, 3 factorial. Okay, and then let's write down e to the I theta. So we just treat x into I theta, right? I theta plus I theta squared over 2 factorial, I theta to the 4th over 4 factorial. Sorry, should be 3 now, and the next term is the 4th. Let's write down till the several terms. 4 factorial, 5 factorial. Okay, let's write down those terms. And now simplify. And we know I squared equals -1, right? Okay, imaginary number. So I theta, this becomes 1 plus I theta. And here I squared becomes -1 minus theta squared over 2 factorial. And Next is minus I theta. I cube equals I squared times I. So it's same as negative I. So same thing for the I to the so let's see, I to the fourth equals what? 1. I to the fifth should be I, right? Something like that. Okay, and we just simplify those numbers. I to the fourth should be 1, so plus theta over 4 factorial, and plus I theta to the fifth 5 factorial, and I to the sixth equals what? I to the sixth should be I fifth times I, so I times I should be negative 1. Now we combine all the term with I together, okay? Rewrite, and the real number, combine the real number together. So it's 1 minus theta squared over 2 factorial, 4 factorial. And then add all the term with I together and factor the I out. So theta minus I theta cube over 3 factorial, theta to the fifth 5 factorial, like this, right? And then now we look at those two terms. Actually, they are all Taylor series for cosine and sine separate, respectively. So this is even function, that's cosine, and plus I times sine theta. You can see this is how the Euler's identity come from. Okay, and in the future definitely you will see this again. Next thing I want to show you is another interesting thing. We know the number pi. Oh, okay, let's do the number e firstly. Okay, number e is 2.718 something, right? Okay, how we get this number e? So actually e is just e to the 1. Okay, so in the Taylor series, you just replace all the x by 1. So going to be 1 plus 1 plus 1 over 2 factorial, 3 factorial, 4 factorial. Okay, so this number will give us this number. Okay, number 3, pi. Okay, we know pi is a number like 3.14, right? How do we get the pi? Okay, I will show you by using Taylor series. So firstly, we know tangent inverse 1. Tangent inverse 1 equals what? Is pi over 4. Okay, so we know pi equals 4 times tangent inverse 1. And tangent inverse function, the Taylor series is given by x minus x cubed over 3 7. Okay, just write down several terms. And then tangent inverse 1, same thing, we just change all the x into 1. 1/5, 1 over 7, those number. So actually, what is pi? Pi is just 4 times this number. More terms, more accurate. Okay, and this is almost 3.14. This is how we get to the number pi and the e. Is that interesting? So definitely in the future you may see other applications, but right now that's what we need to know. So this is the last section in the series chapter. So our first midterm will just cover till this section. Okay, we can stop here.